All right, today is a pretty low-key sort of video, just a talking head kind of thing, no tutorials or anything like that. I am setting out on a journey to answer what is the best media server CPU? How many threads? How many cores? What frequency? How much energy usage does each Intel CPU generation use? And that kind of thing. And as part of that journey, I am looking to answer the question of, is hardware encoding really as good as everybody says it is? I've been using Intel QuickSync Video, which is the hardware circuitry built into most Intel iGPUs since about 4th gen onwards, I think. I'll put a graphic up on the screen right now, which shows you all the different generations of Intel CPU and codecs they support. I found personally the sweet spot to be around the 8th or 9th gen Intel CPUs. Motherboard availability has been quite good during the RAM price apocalypse over the last couple of years as well. DDR4 RAM wasn't ruinously expensive, but still plenty performant for media server purposes. And so one of the things I've been looking to try and do is try and answer that question. Which CPU should I buy? And obviously there's a whole bunch of other stuff and things that go into determining what that is. PCIe lanes, like I say, core count, energy usage, but also, like I say, transcoding performance. That's the one I'm really looking to answer as part of this video. Now, about 4 years ago, the chaps over at serverbuild.net introduced me to the magic of Intel QuickSync. This is the hardware encoder, which is part of your iGPU, the integrated GPU, which is a part of your Intel CPUs, although not all of them. If you have an F variant, I believe, that doesn't have an iGPU in it. But almost all other Intel CPUs have an Intel iGPU, integrated GPU, in them. As part of that iGPU, there is a little hardware circuitry, like ASIC, which does hardware video encoding. Intel call this QuickSync, and it is monstrous for doing things like encoding H.264, 265. Some of them support VP9, and the new Intel Arc discrete GPUs support AV1 as well, which is the future, no doubt. But for now, most of us running media servers and doing things like Blue Iris boxes and things like that, mostly looking at H.264 and 265 performance. So what I want to do is figure out which Intel CPU and which QuickSync GPU is the best bang for buck. Which one gives us the best frame rates? Which uses the least energy? And do the newer generations, which support different codecs, perform any better than the old ones on the old codecs? These are the kind of questions that we kind of see answered in forums all across the internet, with people going, yes, but my CPU does this and my CPU does that. And we never actually get any real data to compare these things. So if you have a look down in the description, there'll be a link to a GitHub repo where a friend of mine, Morgan, Captain Morgan, he goes by on GitHub, has helped me put together a script for us to try and benchmark Intel iGPUs, QuickSync GPUs. What it does is it takes together some old drone footage of mine, which I've edited together, into a 2-minute clip. And we take that 2-minute clip and I exported it from Final Cut in H.264, in 4K and 1080p. I also did it in HEVC, or H.265, in both 4K and 1080p, but also 8-bit and 10-bit color as well. Now, most folks, when you're building a media server, will just say, don't bother trying to transcode 4K. However, we've all got those people that try and, sometimes even me, we've all got those people who try and use our media servers that watch it on a phone, or the Plex client defaults to 720p, or whatever it might be. And so there will be situations, however hard you try, where you end up transcoding 4K. And so it's important for us to have a pretty good benchmark of what's going on in the background. So what this script does is it downloads those videos from an S3 object storage that I've got up on Linode. It then uses the Jellyfin Docker container, because Jellyfin ship a patched version of FFmpeg. And I figured, why go to the trouble of shipping a bespoke test environment when Jellyfin are going to maintain this thing, update it, and also we can kind of leverage some of their expertise if we need to interpret the results later on. Also, you're going to be probably transcoding video more often than not using something like a Jellyfin or a Plex anyway. So it kind of made sense to me to just use the FFmpeg that's built into the media server we're going to be using anyway. So what the script does, like I say, downloads the video, transcodes a CPU test, so it uses all the cores and threads of your CPU natively. It runs the test in Docker, so this reduces environmental differences between different systems, all that kind of stuff. It means we don't have to worry about host operating system quite as much. You will need to install Intel GPU tools and JQ and make sure that your Intel drivers are working, so you can check that with VA info. There'll be a link to a blog post with full instructions down in the description as well. So once the CPU test has been completed, the next thing it will do is it will fire up an H.264 hardware encoding check. Then it does a couple of other things with H.265 and 8-bit and 10-bit, as I said. We could expand this script to include NVIDIA GPUs as well if we want to, because I know a lot of people that have media servers, certainly before QuickSync was so popular, liked to do NVIDIA. I say liked. This was, when NVIDIA had limits on the number of streams and the number of encodes you could do. I think there are patches to remove that kind of stuff now. I'm not really an NVIDIA guy in a media server. I'm all about energy efficiency and reducing the amount of PCI slots in use and all that kind of stuff, which is one of the reasons QuickSync is so fantastic. It's built right into the CPU. I don't need a discrete GPU. I don't need all the power requirements it has, all the rest of it. So what I want to do is kind of get an idea of the rough total system draw. So if you have a kilowatt or some kind of Tasmo to smart plug, just give me an idea of the amount of energy your system draws at idle. And if you could stop anything else the server's doing whilst you do the test, which takes 5 to 10 minutes at most, I would really appreciate it so that we get a nice even baseline. If you give me an idea of how much energy the server uses at idle, and then just keep an eye on the kilowatt as it's running the tests and sort of figure out what the peaks and troughs are, and just give us a rough idea. We're not scientists here. It's not a controlled experiment, but it would be nice to know that kind of stuff. The reason this has come to the forefront of my attention at the moment is because I've got the itch to upgrade my server, and I've got an i5 8500 server, CPU in my server in the basement. And I wanted to make a judgment call as to whether going with an AMD system and Ryzen or something like that has a lot more PCIe lanes available, and then a discrete Intel Arc GPU made sense versus just doing CPU encoding the whole time. So does it make sense for my CPU to transcode these files in software, or is the energy reduction of hardware, is that juice worth the squeeze? That's the question I'm trying to answer here. And I need your help to do that. So take a look for all of the resources down below, and hopefully you can help me figure out just exactly what is the best bang for buck CPU. Collating the results is something I'm going to also need a bit of help with. I'm not an Excel graph wizard. So if you are, let me know down in the comments. You can join me over on the self-hosted Discord server as well. There is a dedicated Perfect Media Server channel on there, which is where we're going to be talking about all of this QSV QuickSync video. It's where we're going to be talking about all that testing. And that's it really. I'm going to make a follow-up video in the next month or so to go through all of these different results as they trickle in, and try and figure out and try and answer once and for all just what is the best media server CPU.